We're going to look at solving inequalities by multiplication and division. Alright, so look to see what happens when we multiply by negatives or positives, and then we're going to see which way that sign will flip. So first off, 12 times negative 3 is negative 36. And 6 times negative 3 is 18. Which is smaller? Negative 36 is. I'm going to repeat the same steps for both questions. And then on that first left, notice that I'm multiplying by a negative value. And on the right, they're all positive. What do you notice? So this was my original, 12 is greater than 6. And then look to see what happens when I multiplied by negative, which was this column here, and then when I multiplied by positive. If you noticed, my sign flipped when I multiplied by negative, but stayed the same when I multiplied by positive. Let's do the same for division. Oh, I must have multiplication on my brain. All right, so that first left column is when I divided by negative, and the right column is when I divided by positive. Here is my original. Once again, when I divided by negative, my sign flipped. And when I multiplied by positive, the sign stayed the same. So in order to make that statement to be true, I had to flip the sign when I divided by a negative. It stayed the same when I divided by a positive. So here are the properties. When each side of an inequality is multiplied or divided by the same positive number, the resulting inequality is still true. But when each side of an inequality is multiplied or divided by the same negative number, the inequality sign must be reversed for the inequality to remain true. So we're going to solve the following. And my first, I got to get s alone by dividing by negative 5. What I do to one side, I have to do the other. And I must remember to flip my sign because I divided by a negative. In B, I'm dividing by 7. 7 is positive, so my sign stays the same. To get y alone, I'll multiply by negative 4. What I do to one side, I do to the other, and I must remember to flip that sign because I multiplied by negative. In D, I'm multiplying by a positive value. I don't have to worry about flipping that sign. Stays the same. So here's more examples. State whether you would reverse inequality sign to solve each inequality. Solve the inequality graph. So A, would you have to flip or reverse that sign in order to get s by itself? Yes, because I'm dividing by negative 5. To graph, I'm going to find negative 5, and I'm going to color in the dot. S is greater, so I'm going this way. For 7, A is less than 21. Divide by 7. I don't need to flip the sign here. because I'm dividing by a positive value. I find -3. It's an open dot because -3 is not included, and a is less than. So all my values that are smaller. All right, here we have a inequality with variables on both sides. I'm going to add 2.6 just so that my variables stay positive. And then move my number over. So I'm going to add 5.2 to the other side. And then divide by 4.4. We get 4.5 is greater than 8. To verify this solution, first I'm going to plug in 4.5 into both sides to make sure both sides are equal so that I know that was that turning point. And I know my sign is reading greater than. I could also change it over to that equal sign just so that I know that I should have both sides being equal to each other. Because 4.5 is that point where it would change over. Oh, and sorry, this, that should be a 2. That was my mistake. There we go. So 2.9 equals 2.9, which is good. Now that I want to make sure that the sides read true, I'm going to choose a value that's bigger than 4.5. So I'm going to choose a value such as, smaller. My a value is smaller than 4.5, so I'm going to go with something like 1. 1 would make it easier, or even 0. 0 is less than 4.5. So I'm going to plug in 0 for a, and I should get that the left side is greater than the right side. I'm not going to put my symbol yet because I'm going to make sure it reads true. And is 14.6 greater than -5.2? Yes. So that symbol, the left side, stayed greater than the right side. So that's how I verified. First, I verified with 4.5 to make sure the left side equaled the right side. I was good to go. And then I verified with a number that was less than 4.5 to make sure that the left side stayed greater than the right. A super slide charges $125 to rent a mat and $0.75 per ride. Haru has $10.25. How many rides can Haru go on? Choose a variable, then write inequalities to solve the problem. All right, so $1.25 to rent the mat plus 75 cents per ride, and Haru cannot go over 10.25. He can spend up to $10.25, but nothing over. So that's the symbol I'm using. I need to get x by itself. So I'm going to subtract both sides by 1.25. And I get 9. Divide 9 by 0.75. And I get 12. So Haru, can do maximum of 12 rides or less, 12 included. No, I'm going to have to do a new number line because it doesn't go up to 12. Okay. There we go. So 12 is included, so I get to color in the dot, and I have to go less than. There you go. You can work on your practice questions now.